Okay, we're looking at mixed exercise 11 from the first year textbook on vectors. We're on question 8, so we've got an exam question. Okay, now they've just thrown a few different ideas together here. So we've got a resultant of two vectors. So a resultant is going to be adding them together. And then we're told it's parallel to vector C. So we've just got to be a bit careful with this idea of them being parallel. So first of all, well, the resultant of A and B, so we'll just be those added together. I'm going to write them as column vectors just because I find that a little bit easier. So I'm going to write vector A as 4 minus 3 and vector B as 2p minus p. Okay, so I can then write that as a single vector. So 4 plus 2p and minus 3 minus p. Okay, so where you just got to be a little bit careful is it doesn't tell me that that equals 2i minus 3j, it tells me it's parallel to it. So 4 plus 2p minus 3 minus p. Okay, so again, I'm going to work in column vectors. So 2i minus 3j would be 2 minus 3. That's not totally complete what I've written there, because as I said, it's not they equal each other. It's that they are parallel, so they are multiples of each other. So I am going to use m. We often use mu or lambda, the Greek letters here. It really doesn't matter as long as you don't use p or a and b, because we've already used those, or I and j, or x and y. Does that get confusing? You can use any letter you like. Okay, so this is going to work because basically now I've got two equations. So if I look at the top row, I've got 4 plus 2p is 2m. And if I look at the bottom row, I've got minus 3 minus p is minus 3m. So I've got two equations and two unknowns. I want p, so it's going to make sense to eliminate m. You've got a few options. You could make m the subject of one of them. I think what I'm going to do is make them both equal, well, make the top one equal 6m. So I'm going to multiply through by 3. And I'm going to make the bottom one equal minus 6m. So I'm going to multiply through by 2. And then if I add them, because if I add them, 6m plus minus 6m will cancel. I'll get something just in terms of p. So I'm doing 12 plus minus 6, 6p plus minus 2p. So then from there I can say 4p is minus 6. So p is minus 6 over 4. So minus 3 over 2, or minus 1.5. Okay, so right, so then find the resultant of A and B. So I'm looking back to this. I haven't found M, so actually I think the easiest, or how I would do this, is I would just go back to this and substitute P into that. So this is part B. So 4 plus 2 and P is minus 3 over 2. And then minus 3 minus p is just going to be careful. You can't see what I'm writing. Okay, that's right. Let's move that up and try that again. Okay, so I've been using, I'm looking at that vector there, and all I'm doing now is substituting this value of p that I found in. Okay, right, so let's finish that off. So what's that going to give me? So it's going to give me 4 minus 3, and then minus 3 minus minus 3 over 2. So it's going to be minus 3 plus 3 over 2. So that is going to be 1. And then what's that going to be? Minus 3 over 2, I think. Let me double check. Oh, for goodness sake, sorry. Still can't see that. Right. Okay, I'm going to double check that last one because I was flopping around a bit there. Let's just double check. Yeah, so we're good with our values. Yeah, actually that's worth being aware of. So I changed to column vectors just purely because I find them easier to work with. But the question was in I and j, so I should really write it back as an I and j vector just for the final answer there. Okay.